Okay, for the next part of this lesson, we are going to review, and when I say review, I mean review. I pulled up, these are notes from the first semester. I've referred back to them several times over many lessons. This is notes number 16 from the first semester, so it should be way up at the beginning of your journal. I literally did a cut and paste. I cut these 4 steps right here, and I pasted them onto our notes right there. So you can tell that's where they come from. Because finding an inverse is exactly the same for squares and square roots as it was when we were just doing it for linears or for exponentials and logs or for whatever pair of inverse functions that we are finding it for. The steps are the same. So we're going to work a couple of examples about finding the inverse, and we're also going to have to stress or worry about the domain, and I will talk about that as we get there. So our first example is up next. Okay, for example number 1, you are being asked to find the inverse. Don't forget, this is the notation for inverse. It's f. It looks like it's being raised to the -1 exponent, but it's not an exponent. It's just a symbol that stands for notation. Find the inverse of f. And then here they give us the function that they're going to call f, the square root of x minus 5. So the steps over here say, first of all, we have to rewrite this as a y. And that's because it's in function notation, so we need to replace the y, the f of x with a y. And when we now rewrite it with a y, we're going to switch the x and y, because that's what you do with an inverse. You switch the x and y. So this becomes x equals the square root of y minus 5. Step number 3 says solve for y. We've got to get the y by itself, so we've got to undo the things that are happening to y. This is the square root. We are going to undo the square root, but not yet. Then it says minus 5, so we've got to undo that minus 5 by adding 5 to both sides. And that gives us x plus 5 on the left side of the equal sign, the square root of y on the right side of the equal sign, and then the last step is to get rid of the square root. How do we get rid of the square root? We square both sides. Now be very careful. This is going to require you to multiply it out. Actually, you don't even have to multiply it out. I'm going to say that there's really no need to multiply that out, because we can see that this is a quadratic. We can leave it in, when it's in this form right here, it's in transformation form or vertex form. So we can see where the vertex of that is. So we have it now as a quadratic. Can you multiply that out and get it in standard form? Absolutely. Go ahead and multiply x plus 5 times x plus 5, and it'll be in standard form. There is no rule that says what form it needs to be in. It does ask me to rewrite it in function notation, so I'm going to rewrite this so that it says the inverse of f is equal to x plus 5 squared. I actually like it being in this form for 2 reasons. One, you can see that we started off with the square root function and we ended up with the squared function. That should make you feel good, because square roots and squares are inverses of each other. We started off with a minus 5 on the outside. We ended up with a plus 5 on the inside. That should make you feel even better, because the inverse operations should have the opposite transformations. The transformation on the square root function shifted down 5. If we switch the x and y, this one's going to be moving to the left 5, and that again should confirm. Remember that this function looks something like this, and if you don't remember, you can graph it on Desmos, but it looks something like that. And then this function right here, remember, is going to look something like this. Now we do need to talk about, this just has 1 branch. This thing right here has 2 branches. This domain was automatically restricted because we were only looking at 1/2 of this. So we need to restrict the domain of this one so that it's truly a reflection. So we did never have to worry about restricting the domain of quadratics because they could be anything. But now, since we don't want that whole graph, we only want this one, this one branch, we got to decide, is it this side that we're going to keep, or is it this side that we're going to keep? Okay, so I'm going to use Desmos to show you these two functions and to kind of show you a really quick, easy way how you can figure out which side you need to keep. I took the f of x equals the square root of x minus 5 and I went to Desmos. And then I took the inverse that I found and I went to Desmos. So here I typed in the function that was given, and you know what? You could have totally put f of x there. It's not necessary, but you could put f of x. I put y. You'll see it didn't change the graph any at all. I then graphed the inverse, and it shows up over here, and it's really easy to see that we have too much of this graph. We don't want the whole thing. We only want either the right branch or the left branch, and so you need to figure out which one it is. What I did was I just went to the graph that they gave us and I picked a point. It doesn't matter which point. I picked the point 9, 2. On the inverse of the point, on the inverse function, the point is going to change to what? We switch the x and y. It's going to change to -2, 9. And you can see that it's on the right branch. So we don't want the whole parabola. We only want the part that starts right here at -5 and goes this way. So we want the x values that are bigger than -5. You can put that restriction right here by putting the little brace and saying that x has to be greater than or equal to -5. And as soon as you type that in, the other half of the function turns off, and we're left with the part that is the inverse of this one. And you should be able to see the y equals x line. That's the line that it is reflecting about. So this was the given function. We did the math here. We got the quadratic, but we recognize that the quadratic is too much. So we want to say comma, restrict it so that we're only doing the x values that are greater than or equal to -5. And that would be the part that you would need to put to make sure that we understood that we're not talking about the entire quadratic. We're only talking about one half of it.